Kia ora, year 12 and 13. Here are some of the harder questions from Delta 34.10. I promise I'll try to keep this short. So here we are practicing writing sums as products, and the formulae that you need are on page 329. So this first example is a cosine of something minus a cosine of something else. So the rule that we're after is this one here, cos alpha minus cos beta is equal to 2 times the sine of half the sum times the sine of the difference backwards, half of the backwards difference. So in here I find it easiest to do the working off to the side. So the sum will be alpha minus 30 plus alpha plus 30. That will be the sum, and that's 2 alpha. Okay, for the difference we have to reverse it. So we're looking at this minus this, not the other way around. So it's going to be alpha plus 30 minus, and then brackets to make sure you don't muck up your negatives. You get, the alphas go and you get 60 degrees. And remember, we've got to half those. So we're left with, let's just put that over there in a little box. So cos of alpha minus 30 minus cos of alpha plus 30 is equal to 2 times the sine of half the sum. So that will be, I'll put it in like this, 2 alpha over 2 times the sine of the backwards difference halved. So that's that. So that equals 2 sine alpha times sine of 30 degrees. Right, as I've told you, your special triangles come up all the time. So here's my 30 degree angle here. This is a 1√3 triangle. And there's 2, so sine of 30 degrees we know is equal to 1/2. So that equals 2 times a half, 2 over 2 sine alpha. So it's just sine alpha. Right, sorry about trying to squish so much onto a slide, but there you go. That's the first one done. On to number 12. Right, writing the product, sine 2x plus y plus sine of 2x minus y. So this is one where it's going to be 2 times sine half the sum cosine of half the diff. Right, so let's work out the sums and differences. We've got 2x plus y plus 2x minus y for the first one. So that equals 4x for the sum, and the difference will be 2x plus y minus 2x minus y, which is 2y. So, popping all that over there, we get this is equal to 2 times sine of 4x on 2 cos 2y on 2. That is shockingly messy. Let me do that down here. 2 sine 4x on 2 cosine 2y on 2, which simplifies to give me 2 sine of 2x cosine of y. Okay, so that one should have felt quite easy. Now the next one I'm going to do is similar, but uses one of the rules we learnt earlier. Right, so this last one, you look at it and it looks weird. The other ones have all had a sine and a sine, or a cosine and a cosine. So this is a cosine, take away a sine. In order to use the rules on page 329, we have to force it to fit the pattern sine something plus sine something, or cosine cosine. So a couple of choices here, but the easiest thing to do here is to say, well, we can switch between cosines and sines by remembering that the angles in a triangle add to 90 degrees, and so the sine of 90 take away beta is just the sine of beta. Okay, so doing that more slowly, and we did this very early in the unit, if I've got beta here, this angle up here must be 90 minus beta. So the cosine of 90 minus beta is this side here over this side here, which is the same as the sine of beta. So sine of beta minus sine of alpha is all we're finding out here. So we're writing that one as a product. So once you recognise that, all we have to do is to say this is 2 cosine half the sum sine of half the diff. It's straightforward application of the rules on page 329. Okay, so the sum is 2 cos beta plus alpha on 2 times the sine of beta minus alpha on 2. Right, so whenever you see a difference or a sum that's got a cosine and a sine, look at taking the complement of one of the angles to flip either the cosine to a sine or the sine to a cosine. Right, that's all for now. I'll do some more of this exercise later on today.